Now let's see the Faraday's second law of electrolysis, which again talks about the formation of the molecule. That means again it talks about the quantitative aspects of the electrolysis, that how much substance will deposit. Now let's see the law first. So the law states that when same amount of electricity is passed through different electrolytic cell, then amount of substance deposited So here we have the law states that when a same amount of electricity is passed through a different electrolytic cell containing different electrolytes, or I can write here electrolytic solution. So when the same amount of electricity is passed through the different electrolytic cell, or from the different electrolytic cell which is having the different electrolytic solution, then the amount of substance deposited is directly proportional to their chemical equivalent mass. That means the substance which will have the higher equivalent mass will have large amount of electricity. The substance which is having a higher chemical equivalent mass will deposit more, and the substance which is having a lower chemical equivalent mass will deposit less. For example, suppose here I can say that I have two cells. Okay, so here we have two cells. The first cell is containing the zinc sulfate solution and the second one is containing copper sulfate solution. Both the cells are connected in a series. That means connected in series means if whatever the amount of electricity is passed through this cell, exactly the same amount of electricity is passing through the another cell also. Molten zinc sulfate is taken. That means here we have zinc ion and sulfate ion inside the container. So let I'm talking about the formation of zinc ion. The sulfate is also there. Similarly, here we have copper ions and the sulfate ion. So in this case, the zinc ion, the negative ion is same, that is the sulfate ion is same, but the positive ions are different. So here let's talk about the positive ions only. So during the electrolysis, the zinc ion will deposit, it will move to the negative electrode and will get deposit here, and the copper will deposit again on the negative electrode, that is the cathode. So zinc and copper both are depositing. Then how much amount of zinc and copper will deposit here? According to the Faraday's law of electrolysis, it depends upon the chemical equivalent mass of the zinc and the copper. The one which is having the higher equivalent mass will deposit more compared to the one which is having a lower equivalent mass. So here I can say that the mass of a substance deposited, that is a weight, is directly proportional to the equivalent mass. And this is applicable only in those cases when the same amount of electricity is passed through both the solution. And so here I can say that the mass of zinc upon mass of copper is equal to equivalent mass of zinc upon equivalent mass of copper, I can say. Okay, so we have equivalent mass of zinc upon equivalent mass of zinc upon mass of copper is equal to equivalent mass of zinc upon equivalent mass of copper. Now, how to calculate this equivalent mass? Then simply I will say that equivalent mass, for which we have a formula. It is equal to, the formula is molar mass, or if it is an element then it will be atomic mass upon valency, the valency of the particular ions. Valency, that is a charge present on the ions in a solution. Like the zinc is having valency +2. Similarly, the copper is also having a charge 2. That means the valency will be 2. So what will be the equivalent mass of zinc now? So here I can say that equivalent mass of zinc is equal to, the atomic mass of zinc is 65.4 divided by its valency is 2. So I can say that 2 3s are 6, 2 2s are, and this 32.7 is the equivalent mass of zinc. Similarly, let us see what is the equivalent mass of copper. So at least we will come to know that which substance will deposit more. The equivalent mass of copper is equal to, the atomic mass for copper is 63.5 upon charge is again 2, that is valency. 2 3s are 6, 2 1s are, and then 2 7s are. That means it's a 31.7 gram. 31.7. So I can say that here the zinc, its equivalent mass is more, so it will deposit more compared to the copper whose equivalent mass is less. Okay. Now in this case, as I said, since both the cells are connected in a series, so the same amount of electricity is passed through it. Now let us confirm the answers, means which will deposit more. Let us confirm the law on the basis of the mole concept, as we determined for the during the first, when we use the first law of electrolysis. Now let us see whether the law is correct or not. So here I can say simply that if I am passing the same amount of electricity, if the same amount of electricity is passed, the electricity same, that means same number of moles of electron will produced. That means equal number of moles of electrons are produced through both the cells. So here, let I am passing 1 Faraday of electricity from both. If I am passing 1 Faraday of electricity, 1 Faraday of electricity is passed, that means I can say that I am passing 1 mole of electron from both the container. Now let's talk about the zinc. So here the zinc have the +2 charge. So reaction will be +2 electron will form 1 mole of zinc. So 2 moles of electron produces 1 mole of zinc. That means if I am taking 2 Faraday of electricity, then it will deposit 1 mole of zinc. And so if I am passing 1 Faraday of electricity, that means it is going to be half mole. Half mole, that means 1 mole of zinc is equal to its atomic mass. So 1 mole of zinc is 65.4. So half mole will be 32.7 gram. So if I am passing 1 Faraday of electricity, that means I can say that how much zinc is deposited, 32.7 gram. Now let's see the same thing in case of copper also. For copper, the reaction will be Cu2 plus 2 electron will give you Co. That means if I am passing 2 moles of electron, then 1 mole of copper will deposit. Or I can say if 2 moles of, for depositing 2 moles of electron, 2 Faraday of electricity is required. So 2 Faraday, then here I can say that 1 mole of electron, 1 mole of copper. So if I am passing 1 Faraday electricity, then here half mole, and so that here I can say 1 mole is 63.5. So half mole is 31.7 gram. So here on passing of 1 Faraday of electricity, this deposited is 32.7 while this deposited is 31.7. So from mole concept also says the same thing, that if you are passing a same amount of electricity from both the container, then the substance which is having the higher chemical equivalent mass, that is the zinc, will deposit more compared to the copper which is having a lower equivalent mass. And plus one more thing from this, we can say that if I'm passing 1 Faraday of electricity, then 32.7 grams of zinc has been deposited, which is nothing but the equivalent mass of the zinc. And similarly, if I'm passing 1 Faraday of 1 Faraday of electricity, then how much copper is deposited? Then answer is 31.7 gram, which is again of equivalent mass of the copper. Means from this we got a very, very important statement, and it is that if you are passing a 1 Faraday of electricity, that means it's nothing but you are passing 1 mole of electron, which is nothing but equivalent to 96,500 coulombs electricity, which is equivalent to, again, a very, very important, that is it's nothing but the equivalent mass of the substance. That means if you are passing a 1 Faraday of electricity, then substance deposited is equal to its equivalent mass. So what will be the equivalent mass of the substance? That particular amount of substance will deposit. A very, very important statement, that 1 Faraday of electricity produces or deposit a substance equivalent to its the substance equivalent to its equivalent mass. So if I am having a suppose sodium, and if I am passing a 1 Faraday of electricity, then on passing a 1 Faraday of electricity, how much sodium will deposit? Then simply I will say that it will deposit equivalent to its equivalent mass. So for sodium, atomic mass is 23 and its equivalent valency is 1. So 1 Faraday electricity will deposit 23 grams sodium. If I am passing 1 Faraday of electricity, then how much chlorine will deposit? Chlorine, that is a Cl2, I can say, which will have 2 electrons, which is formed from 2 Cl minus. That means there is a 2 minus charge. So valency will be 2. So Cl for Cl2, I can say that it is 71. But that 71 is having 2 charges, minus 2, that is 2 chlorine. So it is 35.5 gram. That means 1 Faraday of electricity will produce how much gram of copper, how much chlorine will deposit? Then 35.5. Similarly, suppose if I am talking about oxygen, that how much, if I am passing 1 Faraday of electricity, then how much oxygen will deposit? Then it will the amount of oxygen deposited will be equal to its equivalent mass. Now oxygen, O2 minus will form from 2O, and each oxygen will have 2 minus charge. That means O2 have 2 oxygen and each oxygen is having 2 minus charge. That means O2 have total 4 charges. So 1 Faraday is equal to the molecular mass of O2, that is 16 plus 16, that is 32, I can say. 32, which have 4 charge, that is a valency will be 4, and it is equivalent to 8 gram, which is equivalent to, I can say that 1 by 4 moles, because 1 mole of oxygen is nothing but equal to 32 grams. So if I am passing 1 Faraday of electricity, that means 1 by 4 moles of oxygen will form. That means I can say 11.22.4 upon 4, that means 5.6 dm cube of oxygen gas will deposit. So a very important statement, that 1 Faraday of electricity always deposit the amount of substance deposited when 1 Faraday of electricity is passed is equal to its equivalent mass. So this is about the second law of electrolysis, according to which the amount of substance deposited is directly proportional to the chemical equivalent mass of the substance.